So in this video, we will be talking about how to solve rational equations, and we're going to go ahead and look at an example where we have 1 over 2x plus 3 is equal to 4. So we can go ahead right now and test a few values for x, but we want to have a general way of solving it. And to do so, we're going to go ahead and multiply the whole equation by the denominator, which is 2x plus 3, giving us 1 is equal to 8x plus 12, where we can go ahead and subtract 12 from both sides, giving us negative 11 is equal to 8x, where if we divide by 8 for both sides, we get x is equal to negative 11 over 8. And we want to go ahead and verify this, so we will go ahead and plug x in for a rational equation, giving us 1 divided by 2 times negative 11 over 8 plus 3. This will give us negative 11 over 4 plus 3, where if we go ahead and multiply or make 3 into a fraction with a denominator of 4, we will get 12 over 4, and we get that it is equal to 1/4. So we write 1/4 down at the bottom, and we can see that we have 1 divided by 1/4, which we can go ahead and separate 1 divided by 1/4, which basically is the same thing as 1 times 4, and we get that it does indeed equal 4. So that's how we can go ahead and solve rational equations like that. We're going to go ahead and look at a different one, giving us 2y plus 3 is equal to 1 over y. So how do we get rid of y? Well, we go ahead and multiply by y on both sides, giving us 2y squared plus 3y is equal to 1. Where we can go ahead and complete the square or just use the quadratic formula, which is what we're going to do. So we have 2y squared plus 3y minus 1 is equal to 0. Well, now we're going to go ahead and get y by itself, which is y is equal to minus 3 plus or minus root 9 plus 8 over 4, which will give us negative 3 plus or minus root 17 over 4. So in this example, we're going to go ahead and look at y plus 3 divided by y squared minus 9 is equal to y. So now we're going to go ahead and solve this using two different methods. Well, first we're going to just multiply by the denominator, which is y squared minus 9, giving us y plus 3 is equal to y cubed minus 9y. And now we want to go ahead and subtract y plus 3 to both sides, giving us 0 is equal to y cubed minus 10y minus 3. So now what we want to go ahead and do is look at the possible solutions we could have. So here we're going to go ahead and erase this and solve our cubic. And we have a possible solution of 1 comma plus or minus 3. But we can see that 1 and negative 1 don't satisfy this equation. So we're just going to cross that out because we have 1 minus 10 minus 3, which is not 0. So we just cross that out. We then will go ahead and get a solution for 3 and negative 3. So let's go ahead and see. We're looking at positive 3, so that is going to be 27 minus 30 plus, or minus 3. So we see that positive 3 is not a solution. So we're going to get ahead and move on to negative 3. And it goes negative 27 plus 30 minus 3, which is indeed equal to 0. So we have a factor of negative 3. So we'll write that down. Y is equal to negative 3. And our quadratic is going to be y squared minus 3y. And that is going to be minus 1. And here we have the remainder being 0, so we don't need to write that down. So we were able to get the quadratic by using synthetic division. So we had 1, 0, negative 10, and negative 3. Drop down 1, multiply by negative 3, add. Now we just repeat the process, and we were able to get this, which is exactly y squared minus 3y minus 1. So we're going to go ahead and write down our equation. Y squared minus 3y minus 1 is equal to 0. We want to go ahead and see which solution is, or what are our solutions for our quadratic that are going to satisfy the rational function. So here we have y is equal to 3 plus or minus the square root of 9 minus 4 times negative 1. That's going to be 9 plus 4, which is 13, over 2. And that is, as far as we could factor it or simplify it. And we have our other two solutions, which are 3 plus or minus root 13 over 2. And we want to see which of these solutions basically satisfy our equation and correspond with the solution being y. So we're going to go ahead and test out negative 3 first, which we see is a extraneous solution because it is going to be 0 divided by 0 is equal to 3, which is false. So we're going to go ahead and cross negative 3 out. So now what we are going to do is look at one of the solutions here. So we're going to have to factor now. So we have y plus 3 divided by y plus 3 times y minus 3 is equal to y. So we could just factor out a y plus 3. And we're going to get 1 over y minus 3 since we basically crossed out a factor of y plus 3. And that is going to be equal to y. So now we just want to go ahead and see what our fraction is going to tell us when we plug in 3 plus root 13 over 2. So we have 1 over 3 plus root 13 over 2 minus 6 over 2 is equal to 3 plus or minus, or just plus root 13 over 2. So here, what we're going to do now is just go ahead and simplify the left side to get exactly this. So we're going to go and get 1 divided by negative 3 plus root 13 over 2, which will give us 2 divided by negative 3 plus root 13. And we're just going to go ahead and multiply by the conjugate, which is 3 plus root 13 divided by 3 plus root 13. We're changing the sign of negative 3 to positive so that we could basically multiply now. And we're going to go ahead and get, the top is 6 plus 2 root 13 divided by negative 9 plus 13, because we have a difference of squares, and we're not going to have the root 13 anymore because 3 times root 13 is 3 root 13, and negative 3 times root 13 is just going to be giving us 0, so we just need to not include that, and we're going to get 6 plus 2 root 13 over negative 9 plus 13, which we could get a factor of 2 from the top, so we have 2 times 3 plus root 13 over 13 minus 9, which is 2, and that will, no, which is 4, I meant, which is going to give us 3 plus root 13 over 2, which is indeed equal to our expression that we have above. So now that we verified one of the solutions, we can basically say that the other one is true, because if we plug in negative, we're going to get the same output. So we have a solution of y being 3 plus or minus root 13 over 2. And there is a hole at x is equal to negative 3. So that is that example. So here we're going to look at 1 over x minus 3 is equal to x squared over 2. And we're going to just cross multiply. So we have 1 times 2 is equal to 2, and 2x, or x minus 3 times x squared is going to give us x cubed minus 3x squared. And if we go ahead and move 2 to the left, we're going to get x cubed minus 3x squared minus 2. We're basically going to see that we have a cubic. And here we basically could go ahead and check how many solutions we could possibly have by using Descartes' rule of signs. So here we're going to go ahead and look, giving us, we have a possible table of how many solutions for positive and negative. We see that there's one sign change and there's no sign change at all. So we have 1. And we're going to go ahead and see the next cubic where it is negative. So we have negative x cubed minus 3x minus 2. So we have 0 because there's no sign change. So this suggests that this is our only table, meaning that we only have one whole solution, which is a real solution. And now we can go ahead and just simply solve this by using the formula, since it is already missing its linear term. So since it has only one solution, we're going to get x is equal to the cube root of 27 over 27. So we're going to use minus b cubed over 27a cubed minus d over 2a plus the square root of everything I just said, minus b cubed over 27a cubed minus d over 2a squared plus negative b squared over 9a squared cubed, which is going to be our solution. And we have positive 1. So this is going to give us 2 instead of the square root, or the cube I meant. So we have 2 plus the square root of 4 and negative 3 squared over 9. This is going to be negative 9 over 9, which is 1. So we have minus 1, giving us that we're going to get x is equal to the cube root of 2 plus the square root of 3. And we're going to also have the negative, which is plus the cube root of 2 minus the square root of 3 plus 1, which is going to be our solution for our cubic. And we're also going to see what its value is. So we have the cube root of 2 plus the square root of 3 plus the cube root of 2 minus the square root of 3 plus 1, which is approximately 3.1958234545. So this is going to be our only solution that satisfies this equation, because we could get the complex solutions, but it wouldn't make any difference since it wouldn't satisfy the equation. Well, they would, but it would be a long process. But we're going to have to test this value now onto our equation, where we're going to get, let's see, 1 divided by 0.1958233. So we're going to just use the first 7 decimal digits. So we're going to have 1 divided by 0.1958233 is the same thing as 5.1066. And now our answer, 3.1958233 squared divided by 2 is going to give us, first let's write down, 10.21328 divided by 2 is going to give us 5.1066, which indeed tells us that this solution is correct, and that is our only solution to our equation, since we could get our other 2 complex solutions, but since there's only one real solution, we only need one. So that's that for this video, and I hope you enjoyed, and I hope you have a wonderful day.